Okay, I think we'll get started.
Well, welcome to Digital Lanjouw, Peter. Very honored to introduce this speaker at the very end, I think, of the lunch last slot. Definitely not the least, Tijm Lanjouw, who is going to talk about the project that he's done in Turkey and Troy, but it's just one of the many things that he does and is interested in and specialized in. He works for the 4D Research Lab in Amsterdam, and I'm specialized in 3D reconstructions. And he's worked in, I don't know, I can't just Italy and Turkey and France and many projects in Amsterdam about heritage, reconstruction, and critically thinking about what to do with it. What I also think is really cool to know around Tijm is that he's not just digitally interested in these things. When he did his PhD on Tel Abyad in Syria, he not only did 3D reconstructions and thinking about reconstruction, he also went and learned how to make mud bricks. So that is how detailed he is about and serious about reconstruction work. Yeah, I think that's, I mean, I know much more about you, but I don't think the audience needs to know that. So.
Okay, thank you.
Thank you for this very nice introduction. Yeah, so part of that was also something that I was going to say myself. Yeah, I work at the Faculty of Humanities, University of Amsterdam, at the 4D Research Lab, which is similar to the Digital Archaeology and Heritage Lab here. We collaborate with archaeology, but also with other disciplines within the humanities, history, conservation, restoration sciences. Yeah, a wide variety of scholars for education, but also for research. So today I'm here to report on one of the projects that I collaborated in, the Archaeology of Archaeology 3D, which is a project I'm going to introduce a little bit later, but specifically on my work on the use of historical photos to reconstruct the excavation process at Troy, famous site, Turkey. Yeah, so in this presentation, I'll be mainly focusing on the sort of methodological and technical side, and also do a little bit of a general project introduction in terms of the analysis and interpretation of all the things we did. We haven't progressed that far yet. That's next stage in this project. This is mainly also meant as a pilot project to test the methodology. Yeah, always good to start with a map. A lot of people probably know where Troy is, but it's on the northwestern coast of Turkey, located very near to the Dardanelles, so the narrow street from the Black Sea to the Mediterranean, located on strategic position in the landscape. Here you see it from above, from a drone picture that we made a few years back. Actually, I have never been at this site. This is the work of my colleagues in the same lab. You see the Dardanelles at the background, and yeah, it's currently located amongst agricultural fields next to a small town of Hisarlik. And yeah, so this is the general geographic area of the site. Although Troy is primarily known as the, from Homeric history and mythology, to which Schliemann, of course, came to this site. It's a multi-period site that has a very long history, archaeology extending over several millennia. So here you see like the multiple phases, site phases from like 3000 BC until 500 AD. So at least 3.5 millennia it has been inhabited. So 10 habitation layers have been identified as a result of archaeological work. And when you hear scholars talk about Troy, they always talk about Troy 7, Troy 6, or Troy 0, etc. So these are the distinct archaeological layers. Part of the archaeology project also to critically look at this kind of layered kind of view on settlement history. So Troy has a research history, archaeological research history that goes back 150 years. Different phases of archaeological research when they're like short phase, but also with longer phase in between in which no archaeological work occurred. And this kind of last 1.5 century of like archaeological discovery on Troy is also sometimes described as an archaeological phase in itself, namely Troy 11. So each generation of archaeologists, here you see the main archaeologists working on the site, but of course they had always a big workforce of people that you see at the background. So each generation of archaeologists created a new Troy by their physical activity of excavating, but also by their intellectual activity of generating interpretations.
Yeah.
Okay. Multitasking. Yeah. So that is where the archaeology project from the University of Amsterdam, initiated by Dr. Gert-Jan van Wijngaarden. This is where his project comes in. So the main aim of this project is to understand better how the excavations at Troy functioned as a research context in which archaeological knowledge is produced. So that's the overarching aim of that project. So I'll briefly discuss the theoretical methodological framework of this project and how our work with the 3D modeling based on pictures is ties in with this. So the approach starts with a couple of assumptions, of which the base assumption is that scientific knowledge is contingent and dependent on the context of discovery. And the context of discovery in the case of archaeology, or one of the contexts, is the archaeological excavation itself. So therefore, we need to adopt a critical approach to excavation as a research context, understanding that many factors influence an excavation as a sequence of explicit and implicit choices and decisions that are made. So in the project, we believe that insight into these factors will increase the information value of archaeological data. And finally, the final base assumption is that archaeological excavation or archaeological research itself is a good method to study old archaeologists and fieldwork. So these are the sub-questions of this project. What was the physical context in which the excavation took place? So basically the site itself and its change and how it changed. To which extent and how archaeological features has been documented. So this refers to these choices that archaeologists in the past made. So what do we consider important archaeological finds that need to be documented and which we don't? So that tells us something about their methodology, their framework in which they're thinking, in the way that they interpreted the site. Also, to which extent have finds been collected and not or not being collected. So how do they define what is an archaeological find and what is not an archaeological find? And to which extent have these excavation results been published? So these are all parts of the project that are currently in the process of being researched. So the main sources of this kind of this study is like all excavation publications that exist and all excavation documentation. So notebook drawings, photographs, film, digital data. Currently, this is dispersed over various places in the world: Istanbul, Troy, Athens, Tübingen, and Cincinnati. So part of the project is also collaborating with these various institutes to kind of get everything together. But this is all still a work in progress. So the second important source is like, studying the archaeology of the past by doing new archaeological excavations in two kind of main contexts, which is the dumps. So all the spoil heaps, the things that they threw away, the soil, with also including the archaeological finds that they didn't want to select, and also re-excavation of old trenches. So they have been backfilled and basically check their documentation as well in these trenches. So with all these kind of things, that was not the part that I was involved with, but I was involved with this question. So what was the physical context in which the excavation took place? So welcome everyone that I've just started with the sort of the general project introduction, with the interesting digital part that's starting about now. So to answer this question, we use digital 3D modeling to create a 3D model of the site. So as I said in the beginning, this is kind of very preliminary. It's also meant as a pilot project to test the methodology. And also very important, so the main aim of creating this 3D model is not to create a nice, pretty picture kind of reconstruction of the site. It's also work that I'm doing myself, but in this case, it is explicitly to first map and document the changing physical appearance of this site over time as a result of archaeological investigations. And then, so that is, and after that, analyze what that means for our interpretation of the site. So my main source with our little research group are the historical photographs of the site that the archaeologists in the past made. So hundreds, maybe thousands, I don't know. We never made a complete inventory yet of the photos exist that document Troy at different moments in time. So during the different campaigns of the archaeologists Schliemann, Dörpfeld, Blegen, and Korfman, and comparing these photos to the current situation, but also with each other, makes clear how extensively the site has changed over 1.5 centuries of excavation, modified by human activity. Next to excavation, also demolition, restoration, but also natural processes of decay and vegetation growth. Some of these processes or features may have been poorly documented. So in the light of archaeology, the question is asked to what degree the excavators were influenced by what they saw and experienced as Troy at the time that they arrived there. So decisions in archaeology are often made relying on an assessment of the visible topography and features, and consciously or subconsciously influenced by previous archaeological activities, therefore. So we ask ourselves, what if we can use these historical photos as sources for a type of virtual archaeology, investigating and reconstructing the changing appearance of Troy, and use this as the gateway for archaeological decision-making in the past. So my contribution mainly in developing the methodology for this new practice, which I'll focus on in the remainder of this talk. So in my other work for the lab, I do a lot of 3D reconstruction, digital 3D reconstruction, and I often use historical photos to reconstruct historical spaces. For instance, this is an example of a 1922 exhibition in a Dutch museum that doesn't exist anymore. We had a couple of photos, an exhibition plan, and with these in the 3D modeling software that I'm using, Blender, I'm positioning these photos, aligning the perspective with the plan, and from there start modeling the walls. So in the case of architecture, it's a relatively straightforward process because I can use these straight parallel lines that have a common vanishing point to align the photo with a site plan, for instance. In the case of archaeology, with all the irregularity and messiness of sites, it is a little bit more difficult than that. But we still thought like, well, let's give it a try and see what we can do. So This is a video giving a walk through the methodology. So it revolves around reconstructing the original positions and orientations of photographs. First, a reference topographical model was made by removing vegetation of a drone photogrammetry model. And this treeless model of the site was used as a reference for locating, orienting historical photographs based on matching features that are still visible. This is a manual, very labor-intensive, iterative process in which a best fit is strived after, and often multiple slightly differing reconstructions are possible. So virtual render cameras in open source 3D modeling program Blender are used to represent the historical photos. So after orientation and position is determined, and I'm still like fiddling a little bit with the location photo. So yeah, after it is determined, the archaeological features seen on the photographs are projected back in 3D and modeled as simple volumes and surfaces. Both lost and still existing archaeological features were modeled in this way, but also physical traces and objects resulting from the activities of past archaeologists, such as railway tracks and spoil dumps. 5 different people, students, lab employees, and interns were responsible for the camera positioning and modeling of these features. And since we consider this as a type of virtual re-excavation of the site, we also made sure to record this and document these activities, so our interpretations. So a simple sort of, a feature for online people, maybe turn off your mic.
And stop drawing on the screen.
Yeah, so I was talking about, so we created a simple feature form inside the 3D modeling software to record these, the activities of these virtual archaeologists doing the reconstruction. So this video is representing, so there's basically, when you're working in 3D modeling software, there are basically 2 ways of getting pictures inside 3D modeling environment. So this one is to illustrate explicitly that we're not sort of just importing the picture as a 3D model and place that in the environment. No, we're using cameras. So the second thing that you're seeing here, that yellow, now white frame thing, is a camera, which has a single viewpoint. So it is basically reconstructing this single viewpoint that the photographer take. So you cannot look at it from other sides, other directions. It is purely looking through the lens of this camera. So that is something that we wanted, because if you import just the pictures, you can still look at it from all sides and getting with different, seeing and looking at it from different perspectives. So this is an important part of this methodology. So we worked on this a couple of weeks, I think. So mostly these interns and students. This overview of the results. So this is mapping out our virtual archaeological activities on a model of the current site. So you can see we focused on 2 different areas. So on the left, it is the area near the southwest ramp, and on the right, the area around the southeast gate. The yellow wire object, the small ones that you see in the picture, those are all the camera positions that we reconstructed. And the white, objects, simple forms, that are the archaeological features such as walls, rubble piles, railroad tracks, and walk levels. In addition to this, we worked on determining and classifying dump areas from historical pictures on the north side of the mount, but these are just not visible, but they will come in a example next. So in total, we reconstructed 187 camera positions and 189 features from these photos. So now I'm going to discuss some specific examples. So one case is disappeared archaeological features. So here, colored on this old photograph, are, by comparison with the current site and other photographs, are features that have disappeared. So a lot of these features that I've seen here, so part of the city wall, some wall structures on top of it, and a collapse, basically part of a wall collapse that came down from that on top of the city wall, the citadel wall. So these elements were documented by this photo by Dirkveld in the 1890s, but 40 years later in Blegen's time, if you compare these pictures, they're already largely gone. So they removed part of the citadel wall, they removed those walls, or actually they deterred into a pile of rubble, and they removed the collapse. So this is how then in the 3D model, so you see here the drone photogrammetry model, and here sort of, roughly outlined these elements that we saw on the pictures using this photo reconstruction methodology that I described just now. So another case, we thought, like we saw in a lot of pictures, these railroad tracks, but you thought, oh, well, let's try also to reconstruct those, because they can tell us something about like where the dumps of these phases in the archaeological were already. So they're leading to dumps. They're in between like the excavation area and where they dumped it. And because there's a lot of dumps, there's one of the questions is like, which archaeologist in which time created which dump? And one reason to reconstruct it would be like to find where these railroad tracks are running. Unfortunately, we couldn't really reconstruct entire railroad tracks. So at the lower right, you see like that we did parts of a railroad track that we could combine, like 3 photos we can combine. You have one section of railroad track. So we couldn't completely reconstruct an entire line, so to say. But still interesting because it kind of adds to the model sort of the archaeological activity that they use. So the railroad tracks is part of the excavation process. So due to the excavations, a lot of the geomorphology of the site basically changed. So the surface, it was dug out, leveled, all this kind of thing. So you see in this picture a view into Schlieman's Trench, a historical picture. And Schlieman's Trench is famous because it has still these walls visible in it. And you see this also on the historical photo. So we could align these walls with historical photos. And then you can see also how much soil was removed since then on the side. So at the back, you see this white line, which represents the current surface of the mound. And on the side, you see what has been eroded or taken out since. So these are also elements that we then are able to project back on the 3D model and create a model of it. So the spoil heaps, this is another example. So you see them here with different colors. This is again a video. So if you look at, wait a second, I have to play this video, sorry. So if you look at photos of these spoil heaps, if you zoom in, you can see there's some chronological differentiation between them because some look very fresh with recent dump soil on top of them, while others have been already showing more signs of erosion, vegetation growth. And so on these photographs, we see chronological order or stratigraphical order of these various dumps, also very visible on this picture. So we thought like, okay, we reconstruct these using sort of the outline and some trees of the mound, and then draw back from that perspective, draw on the mound where these spoil heaps were located. So that was something we did in the process that you can see here. And then, of course, we can look at it again from the top and create also a image again from the top. And because we're working in a geo-referenced Blender or 3D modeling environment, we can make a render and use that in GIS again. Also, where we can compare this data with the spoil heaps reconstruction based on historical photography. And well, well, one of the things that you see is that like from the air photography, you see much larger areas, but there's an interesting correspondence between them, but also the historical photographs show more detail in terms of chronological diversity. And this is still something that we have to assess and interpret the meaning of. So the preliminary results, summary. So the 3D image mapping completes the existing 2D mapping by adding heights to all the walls and features, etc. We identified various undocumented modifications, so removal of stone layers, restorations. We were able to roughly estimate the heights, location, and extents of the old spoil heaps. And there's another admission. And it also showed us with this pilot the potential of reconstructing the original and intermittent site surfaces. So a little bit too early, for instance, we also hoped that we could find some like features that were not completely not documented and were like removed in the excavation process. So far, we haven't gone into this detailed comparison yet with known site plans to see if we discovered new walls or something. But we discovered a lot of modifications. So I have 3 points for the discussion: the accuracy of the modeling and the method, possible suggestion for improving, optimizing the method, and something about standards for virtual documentation. So one of the main points of discussion is the accuracy of the method. So one cause is our lack of knowledge about camera and lens properties of the original cameras by the excavators. So people that have done photogrammetry and know a little bit more deeper photogrammetry than just a checklist in Metashape know that photogrammetry software uses all kinds of lens distortion modeling in order to correct for this to make accurate 3D models. We do kind of the same project, but then completely manual based on single pictures. But it would add to the accuracy of the method if we could also add lens distortion parameters inside the 3D modeling software Blender that we're using. So that would mean that like one of the possible further developments is do some kind of add-on development for this software to improve this the accuracy of the cameras, but also to do research into the historical photo cameras that the archaeologists used in the past and try to calibrate those with the process on the right. But I think the biggest cause for inaccuracy is not the lack of knowledge about the cameras or the distortion factors, but is the difficulty of aligning the photos to the 3D model. So I'm now giving an example of this with the walls near to the southwest ramp. The ramp is at the bottom, and then there's some walls like just a little bit on top of that. These walls have disappeared since, but they have been documented in the past. So I did make a reconstruction of these walls based on my photo reconstruction, and also 2 others did. And then we can compare and see how they diverge. So this is the first reconstruction based on the first attempt. And someone else did this using the same photos, created something that is like slightly aligned a different way and also slightly different kind of models. And then someone else made some walls over here. So you can see that how easily you can like get a kind of a range of locations for features that you reconstruct on this method. But at the same time, we sort of have identified a general area. It's not super precise, but we still have sort of an identified. So maybe part of our way to deal with this type of reconstruction based on like imperfect photo alignment is to think about like these are areas of probability for these kind of features rather than like these features are precisely there. And that's also so it's actually good to have multiple people doing the same photos, doing the same reconstruction work, because then we can define these areas of probability. And one thing I also know that like practice makes this a lot better. So when you do this a lot, you become really good at this. So it's really a skill that has to be developed. Oh yeah, so last picture is so when we compare this to the actual locations of these walls based on the 2D plans that we have from this from Troy, and see in white there in the middle, this is the actual location with 2D plans. But there are also questions about the accuracy of that plan. So yeah, so there's in general problem of accuracy of historical documentation of these features. So I think the method could also be improved further by investing again also in another part of software development to enable more accurate camera and lens modeling, but also to add some degree of automation, because it is a really labor-intensive process to kind of align, adjust, and then see another camera, and you have to jump back and forward a lot. There's an advantage to this because as a modeler, you start to look very, very detailed at these photos in a very detailed way. So your observation becomes better because of this sort of labor-intensive process. And that is something that I think it's important to include in the workflow. However, I think it could improve significantly if we could like improve the tools in which we do the alignment in Blender a little bit better. So this is completely different software, which I thought was an interesting inspiration. This is used for thermal photography and on machinery, to map thermal photography on 3D models of machinery. It's open source software called Calcom, and you just click point. You match points manually on photo and on image, and then it does the camera calibration itself and its location and rotation, and then you don't have to sort of manually start rotating, turning around, placing the photo camera. So something like this kind of procedure would be good to have in the 3D modeling software Blender to make the process a little bit more efficient, without making it totally automatic, because then we don't observe anymore. Then the last thing is about standards for virtual archaeology documentation, basically. So we kind of ad hoc created this kind of feature form as custom properties in the 3D modeling package, but we still have to discuss about like, should it be extended? Should we make use of some kind of standard that they're using also in real archaeological fieldwork for documentation of features? So this is something that we still have to talk about. But one thing, the nice thing about doing it in Blender this way, using the custom properties, attaching it to each feature you find, is that you have metadata and 3D objects combined in one object. So if you're exporting this to a very widely used 3D exchange file format, GLTF, it adds these custom properties into the 3D modeling file. So if you're sharing this and people reading this 3D modeling file, and if you develop other viewers that display this 3D model, they can say for each wall what the metadata is that we recorded while we're doing this virtual archaeology excavation. So we're nearly there. So while doing this kind of work, we continuously also try to be reflexive, like how does the 3D modeling add to, for instance, just image comparison. So you can do a lot of this kind of work, like comparing pictures with each other. Is it worth putting all this effort and putting in the 3D cameras in there and creating models like that? But of course, I also formulate a couple of answers to that. So one of the big advantages of putting it all together in a 3D model is that we create a comprehensive spatial context. Like when you're just doing the analysis based on individual or sets of pictures, you always look at two or three pictures. This way, we store everything in an entire environment. That also allows is space for making new observation. while you're working on it and also afterwards. And as I've also already emphasized before, I consider this as a type of slow archaeology. So when you talk about digital and virtual, sometimes the emphasis is on efficiency and fast, etc. But I think this part of like looking at the pictures, trying to align this with each other and with the site is a type of slow archaeology, because you start to like your observation becomes sharper and you start to understand the site from this historical perspective much better. So what it offers as well is the ability to reconstruct lost or altered features, of which you saw a couple of examples already. Furthermore, it is a complete documentation of our virtual archaeological activity. So it's people in the future will also know, if they're looking at this model, who modeled what in what way, and can use this as their base for their work on the site. And further, then it is also becomes a tool for conducting further research. Yeah, that basically was my final slide, and now the main then there's one slide left. I should thank. I was not alone in this project, so the Archaeology of Archaeology project is pretty big, so there's a lot of people involved with this. People involved with specifically this 3D part are, of course, Dr. Gert-Jan van Wijngaard, the project director, Dr. Jittewage, my colleague, doing drone mapping and interpretation of historical aerials. And then there's Alicia Walls, Marco Mion, Steph Knook, and Faith Kalman, who are lab employees and interns of the project. So this was my presentation. Thank you for listening, and if there are questions, I have for you.
That's great. We always like to have it extra challenging by running engines and having users draw on the screen.
Yeah,
just to mix things up.
Don't mention the kid.
Yeah. And bringing a child.
Yeah.
James.
Yeah, brilliant. Really, it's that right in my wheelhouse. I loved it. It was really good, really interesting. Because I've worked on a number of projects where we're dealing with this similar complexity of legacy data on a complex like that. So